Hello and welcome to this hands-on video on using Scikit-Learn and Python. In this video we will go through how to do some KNN classification using Scikit-Learn. Without further ado, let's move on to the code. Here I'm in Visual Studio Code and this is a terminal. Let's just start with virtual environment, source.then bin activate, and then let's pip install Seaborn, Scikit-Learn. Do I need Pandas? Maybe I need Pandas, I'm not sure. Okay, here I think it should be fine, and we will start with a new notebook. Oh right, I forgot pip install IPyKernel to work with Jupyter Notebook. Okay, done. Now let's start this one. Here it's KNN, and I will remove the terminal as it's not needed anymore. I'll change my Python environment here. Okay, let's change it to Python and then import Pandas as PD. We will need import Seaborn as SNS, as I will do some plotting. Import matplotlib.pyplot. Matplotlib was when I installed the Seaborn, I got it for free. Import numpy as np, and then from sklearn.datasets import load wine. There's actually a lot of datasets in Scikit-Learn that you can do some quick and dirty testing on your data on different algorithms. Let's run this one. Then this is the setup, and we'll go into some short EDA. Then we can do wine equals to load wine. And we can take a look into wine. It looks like this, very messy as it looks like in the beginning, but let's take a look. You can see directly it's a dictionary. Then we can take a look into the keys. What do we have in the keys? We have data, we have target, frame, target names, descript, feature names. Okay, then take a look into some other things, such as we can take wine.feature names, for example. You can see here we have the different feature names that exist. Then what else? We can take wine.target names, and you can see, yes, target name 01, etc. Wine target. You can see here it's our y vector. So now you start to get to understand it a little bit. What else do we have? We have target. We can take a look into frame. What is that? Wine.frame, and you can see it seems to be nothing. Let's take a look into wine.keys again to see if we missed something. Frame, target names, what is that? Wine.description. Okay, it's the description of this data. It's a script describing it. To see it nicely, we need to print it. Okay. Here you can read more about it. What is the dataset? Let's see, 178. We have 13 attributes, and these are the attributes, etc. If you want to read it more, you go into text editor. You can see this is the full text. And I think it's good for you to read it. Just do it to understand the dataset. Then afterwards, let's use it to create the things that we want to create. We want to have a data frame. Data frame is pd.dataframe, and that we do wine.data. Then we can do df here. You can see here we have the data frame. However, we have 0 to 12 here. These are the features. We have columns equals to wine.feature names. You can see now we have the data set. It's a data frame with the features. Okay, then we can also do, for example, df equals to pd.concat. We concatenate our df with pd.dataframe, our wine.target, columns equals to wine class. Let's see, and then we can take axis equals 1. Okay, for doing this one, we get the wine class as well. Now it looks similar to the data that we're used to working with the CSV. We get the data with the labels as well, and we extract it later on. But however, I do this because we can do some EDA with it to understand it a little bit more. df.info, we can see here df.info, you can see that, okay, this is int, all other are float, and yeah, non-all or non-null. Okay, then we don't need to clean it. We don't need to remove some nulls, etc. df, we can take a look into wine class. dot value counts to see that, okay, yeah, it's somewhat balanced data set. We can take a look into wine.target. Actually, we have it already. Let me see. We can take a look into this one I want to show. sns.pairplot. We can do a quick and dirty plotting here, df, and we can pick out a few classes that we want, or a few features that we want, for example, alcohol. We can pick out malic acid. You can pick out a few that you want to take a look at. Total phenols, ash, wine class. Then when you do this, let me see, data, alcohol, blah, 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 alcohol, wine, key error. Yeah, maybe there's some key error here. Total phenols. Let me see. Alcohol, malic acid, total phenols. All right, we need to have another bracket here in order to, because we're extracting different columns, then we need to have two brackets here when we want to extract from a list. Okay, this is our plot that looks like this, and we can have a look into, I'll just do some cleaning here. We'll take a look into corner equals true. We just want to show, we don't want the repetition of it, and then I will explain what we have plotted. Hue equals to, let's see, wine class, and we don't, okay, like this. So we can have a palette as well. Palette equals tab 10. Okay, much better. What we have done is that we pair plot different features against each other. What this means is that we have several features here. We have malic acid, total phenols, ash, and then we have alcohol, malic acid, total phenols, and ash. What it chooses is that it chooses all those numerical features and doing the pair plot. The blue one here, it seems to have higher values of alcohol and lower values of malic acid, and the orange class here seems to have lower alcohol values, while the green class here, you can see that the number 2 here, green has more malic acid and higher alcohol as well. Also here in the ash, you can see that all the clusters are really hard to separate. Ash doesn't give much predictive power. Let's move on to taking a look into some correlation now to see if there's more features we should drop or keep. Correlation heat map. To do this, let's change this to Python here. To do this, we do fig, x equals plt.subplots. 1, fig size. I need to change the fig size to, for example, 16,8. DPI equals 150. Then we will do sns.heatmap df.correlation annotation equals true, and then x equals to x. It will look like this. Here you can see that, for example, alcohol to alcohol, the correlation is 1 because it's to itself. What you can see here is, for example, total phenols and flavonoids. They are quite closely correlated, very highly correlated, which means that when one increases, the other one increases as well. They are redundant features. We should remove one of them. In order to know which one to remove, we can see here, we look into how they correlate with the target. The target is the wine class. And as you can see here, we have minus 0.85 for flavonoids with wine class, and total phenols minus 0.72. Minus 0.85 means that it has larger flavonoids, or flavonoids have larger signal to the target. It means that we should remove the total phenols. This one we can drop. Then we can also see that we look into the ash. Here's the ash, and we can see it has minus 0.05. The correlation to the wine class is quite low, and which you also saw in the pair plot before. Here it means that since its absolute value is lower than 0.2, it's very low, we can drop it. And then we look into, okay, magnesium is also quite low as 21, but not as low as minus 0.005. Drop it as well. Then the rest we will keep. Yeah, color intensity could be dropped, but we will keep it. Based on this one, we have a few features to keep and a few features to drop. This is quite good to do, that you do a correlation heat map in order to do feature selection. Let's drop some features. df.drop. I want to drop ash. I want to drop total phenols. I want to drop magnesium. Then axis equals 1, df.head. Now we have fewer features. Now it's time for k nearest neighbor. To do k nearest neighbor, we go into learn. From learn.preprocessing, we need to import a scalar. I will pick min-max scalar here. And then from sklearn model selection, import train test split. From sklearn.neighbors, import k neighbors classifier. Remember, we can use KNN for regression as well. There's a k neighbors regression. However, this is a classification problem. We need to classify. We take the classifier. Here I will just do x, y equals df.drop. Here we want to drop the wine class. Drop the wine class and then comma axis equals 1. Then df of wine class is our y. Then we need to do the x train, y train, and I'll just copy it like this. We have x train, x test, y train, y test. I'll choose a large test size like this. Then we'll do scalar equals to min-max scalar. Then we create an instance of min-max scalar, and we will do scalar, let's see, scaled x train equals to scalar dot fit transform x train. When we have fit transformed x train, we can use these parameters to transform the x test. Scaled x test equals to scalar dot transform x test like this. Okay, then afterwards we can do model KNN equals to k neighbor classifier. We'll choose the number of neighbors. Neighbors equals 1, for example, to make it very simple. Then model KNN dot fit scaled x train, comma y train. And then we do ypred equals to model KNN dot predict on our scaled x test, and we have our ypred like this. We get the different classes that we check. If you take a look into ytest dot values like this, you can see here there's 0, 0, 0, 0, 2, 0, 1, 1, 0, 1, etc. You want to take a look into these, how well they performed, and you will do from sklearn.metrics import confusion matrix display classification report. CM equals to confusion matrix of y tests, y pred. We can have confusion matrix display of cm.plot. Here is the results. It means that we have a lot of true, the 0, we predicted 0, we got 0, we predicted 1, we got 1, we predicted 2, we got 2. Some are misclassified here. Then you can take a look into the classification report in y test and y pred. We need to print it, of course. Print it to make it look nicely, and this is the result. Okay, that is quite neat, but we just picked our neighbors, number of neighbors to consider. We just picked it as 1 arbitrarily. However, if you want to make a hyperparameter tuning, there's 2 choices here. One choice is to use the elbow plot, which gives a visual understanding. I'll do that. Elbow plot to choose K. Okay, like this. In order to do this, we will start with creating error equals to 1 minus accuracy score of y test, y pred. Let's see, we need to get the accuracy score. From sklearn.metrics import accuracy score. This is, for example, the error. The idea is that we will pick this error for each n neighbors. We'll change the number of neighbors, and then we'll calculate an error, and we'll append this error. Then we will do a plot out of this. Then we can do error list as an empty list. Then for k in range 1,50, for example, we'll increase the number of neighbors. Model KNN equals to k neighbors classifier n neighbors equals to k. Then we can do model KNN dot fit scaled x train y train, and then we'll do y pred equals to model KNN dot predict, and we want to predict on scaled x test. Then we'll do error list dot append 1 minus accuracy score, because this is the error, accuracy score of y test, y pred. You'll get an accuracy score here. We'll do fig, x equals plt subplots 1, and then we'll do x.plot range 1. Let me see. We can do numpy np.arrange 1, length of error list. Then we will do. We'll start with this one. Let me see, there's an error, 48 versus 49. We need to add 1 here, off by 1 error, plus 1, like this. Okay, good. Then we want to do dot. Let's see. Dot dash, okay? Or O dash. Yeah, we can do dot dash. O dash. Dot dash. Okay. Dot 1 dash. Yeah, that's better. Okay. Here, y label equals to error. Let me see. Y label equals error. All right, I need to do set. X dot set. Y label equals error. Title equals to elbow plot. X label equals to k neighbors, number of neighbors, like this. Okay, good. What you can see here is that we should pick, for example, 11 here, because here 10 is starting to get the minimum, and then the minimum is continuing. We pick 11 since it's better to pick the odd number, since we don't want to tie in KNN. We pick 11 here. Also, it's better to wait a little bit before and to make sure that it's stable minimum here. Okay, pick 11, and the idea is that when you have picked 11, you train on all your training data. Then there is nothing to evaluate on. That's because we have already used our testing set. We cannot use it again. The idea is that what you should do here is that picked k equals to 11. What you should do is model equals to k neighbor classifier 11. This is the final model that we use, and then we do scalar dot say scaled x equals to scalar dot fit transform the whole x, and then you do model dot fit scaled x comma y. This is it. Then you have the model. You can do model.predict on a future data set that you have. That is the idea. However, you could have changed it so that you used the scaled x train here, and then the model on the y train, and then use predict on the y test. But that is cheating, because that means that you have leaked the data leakage, because you have used the testing data to adjust your hyperparameter. Then you, based on this one, you test on the testing data. This will give you misleading results. What you should do, but I haven't covered here in this video because it makes the process a little bit longer, is that you could divide your training set so that you have scaled, that you have x train, x val, and x test, then y train, y val, and y test, and you tune the hyperparameter based on the validation data, and then you use the validation data together with the training data to predict on the test data, then use the and then do evaluation on the testing data. Also, I haven't shown here, but you can also test out the cross-validation using K-Neighbors classifier CV to do cross-validation instead of doing the elbow plot. But I wanted to show you the elbow plot here. In this video, we have gone through KNN, hands-on with Scikit-Learn. Here we have started with some EDA and gone a little bit more into EDA in this lecture, that you get to know how to work with correlation heat map, and how to work with pair plot to see to do some feature selection, to see which features to keep and which features to discard. Then afterwards, we did use the KNN and gone through the usual Scikit-Learn steps in order to do a classification, and finally did some metrics using classification report and confusion matrix. Then we also tried to tune the hyperparameter using elbow plot to show you how to pick the hyperparameter. But another way to do it that we haven't shown in this video is that to use cross-validation. Also, we discussed about how not to do it, to not leak the data. We don't want to have data leakage. I hope that you learned a lot from this video, and see you in the next one. Bye.